show that you're very excited about the session, and it's a very interesting topic. So I'm sure you'll learn a lot. So before we go into the class, I would definitely. How many of us are expected to join here today? I know it's a festival today, um, and I'm not sure what is the expected size of the class. I can see about 22 people right now, but can do we have a sense of how many of us are expected to join today? What's the size of the class?
I think
There
the
are
total
about
is
32 to
32.
35 students, I suppose.
35. Okay, not a bad number turnout on the first day. I mean, I was expecting a complete 100% turnout, but I understand that it's festival time. In fact, I was told about this session only about 3 days ago, so we still don't have a TA assigned for the course, but we will definitely get the TA assigned by early next week. And also, I think some of the things that we might, for example, today we might just have 2 hours instead of three, and tomorrow we might have three because, again, because it's a festival today, some of you may be busy, so we'll figure that out. So, some rescheduling for the first week, just because we're starting out. It was a festival week. We were just told about a couple days ago that we have to teach. So, I hope that will work out well. But otherwise, it's a very exciting session that we are looking forward to. So let's actually start with a very quick round of introductions, maybe not more than 5 seconds each. We can go in the alphabetical order. Um, and then essentially, let me start recording also. Um, so I hope nobody has an issue with the recording. Yeah. So we can have a very quick round of introductions with everyone, and we can go in the alphabetical order. We'll start from there. Asta Singh, do you want to go first? Just 5 seconds to introduce yourself. What's your background? What have you worked on? So on. Which department are you working in IBM?
Yes, sir. So, I've completed my engineering from SRM University in Electronics and Communication Engineering, and currently I'm working as an analyst in Deloitte. Yeah.
Wonderful. Welcome. Thank you. Ankita.
Okay.
Good afternoon, sir. Um,
Hi.
yeah, I'm Ankita, and I've completed my BTech in 2018, and after that, I joined Infosys, and then I did my master's in electronics and communication itself. So I did my BTech from NIT Jamshedpur, and then I've completed my master's in from Jamia Millia Islamia
Mhm.
recently, and
Mhm.
now I'm pursuing this course. So thank you.
Great. And I mean, so what's your profile of working in? I mean, you completed your masters, but currently job profile is it?
Yeah, actually, recently I've completed it like a few weeks ago, actually, like
Great.
1 week ago. And after that, I was planning to join. Yeah, actually, I was placed in one of Jaro interviews in that company, but I left it because I didn't want to continue with those in that because it was an ed tech company. I didn't want to continue I didn't want to continue with them, but so I had developed an interest in data sciences. So
Data
I
science.
want to do
Great.
it. Yeah. So
Cool.
earlier I also planned to do a PhD, but now I'm not planning to do it currently. So
Sounds good. So you're interested in data science and looking
yeah.
for opportunities. Great. Angad Singh, would you quickly, 5 seconds, introduce yourself, your background, and what's your current profile? Angad Singh, can you hear us? If not, we can go to Anusha.
Hello, sir.
Hi.
Hello. Am I audible?
Yes, you're audible. Please go ahead and introduce
Okay.
yourself. Yeah.
Yeah, I'm Anusha, and I have 3 years of work experience as a software engineer. But currently, I'm not working. I chose this course because I want to move into data science sector as an ML engineer. So I chose this course.
Sir, I think you are on mute.
Sir, you are on mute.
Yeah, thank you. Sorry about that. So I was just saying, Asmita Bhardwaj, do you want to quickly introduce yourself?
Yeah.
Thank you,
Yeah,
sir.
hello, good afternoon, sir. I did my BTech in Electronics and Communication Engineering in 2019
Mhm,
from IGDT University,
mhm.
and
And
currently I'm employed as Network Automation Engineering in Orange Business Services.
okay, network and automation.
Yeah.
Great. We can um, move to Bibek Keshri Sahu.
Good afternoon, sir.
Mhm,
Sir, I have done in BTech in electrical engineering. Then I did my MBA, Masters in Marketing and Operations Management.
mhm.
Now I'm working with Global Data Research Center as an associate analyst,
Mhm.
and with that I'm continuing with the course.
Great. Thank you so much. So you're working with the
Thank you.
Global Data Research Center as an analyst. Great. Dipta Shimitra.
Good afternoon, sir. Actually, I have done my MTech in remote sensing and geographical information system from Indian Institute of Remote Sensing, and also I have done an MC in distance education. My MC project had an element of machine learning in it, so I was interested in machine learning, and I decided to join this course. Currently, I'm not working anywhere.
Wonderful. So you worked with ML before and you're looking for opportunities. Govind Verma.
Thank
Good afternoon, sir.
Hi.
My name is Govind Verma. I am from Chhattisgarh. I am completed my master in computer application in 2011 from Chhattisgarh University. And after that, I am joined Chhattisgarh Software Solution as a network administrator. In 2017, I am joined Air India as a IT and network infrastructure. Right now, I am in Air India, Mumbai, and I am having near about 10 years experience in IT and cyber security area.
Okay.
I know machine learning and deep learning is very important in networking. That's why I'm joining this course.
Great. Thank you. Wonderful. Um, Ira Bajpai.
Hi, sir. I completed my engineering in electronics and communication in 2019. I'm currently working as a data analyst with a consultancy in Noida.
Wonderful data analyst. Um, Nitin Gulati.
Good afternoon, sir. I
Hi.
am a BTech in Mechanical and Automation Engineering and MBA in Marketing as majors.
Mhm.
Presently, I am working with GD Research Center Private Limited as a market research analyst.
Market research analyst. Great. Pleasure to have you here. Mrinal Kumar.
Hello, sir.
Hi.
Am I audible?
Yes, you're audible.
Yes,
Please
sir.
go ahead.
Yes, sir. My name is Mrinal Kumar. I did my BTech from BIT Patna. My branch was Electronics and Communication. Currently, now I'm working in Baroni Refinery as a service engineer. I am doing this job. Is my job is on contract now. So I find this data science subject is very interesting to me. So I want to shift my career to the corporate world. So I joined this course right now.
Great. So you're learning data science and looking for
Okay, sir.
opportunity. Yeah.
Okay, sir.
Yeah. Naman Jain.
Yeah, good afternoon, everyone.
Hi.
Yeah, I hold a BTech in IT, and I have about 4 years of work experience at Infosys as a senior systems engineer.
Great. Pleasure to have you here.
Thank
Pratik
you.
Gujral. Pratik Gujral.
Hi, good afternoon, sir. So, I completed my engineering, electronics, and communication in 2016, and post that I have had multiple. I've worked in multiple areas. I started working with in-vehicle communication networks, how different electronic controllers in a vehicle communicate with each other. then moved on to EMI/EMC, electromagnetic interference and compatibility. Then I was transitioned into IoT data analytics, where I worked with a lot of vehicle sensor data. And now I'm majorly working with sales and marketing data as a machine learning engineer, doing demand forecasting in those sort of projects.
Great, wonderful. So IoT, sensors, and ML. Great.
Yes.
Raunak Datta.
Good afternoon, sir. I
Hi.
completed my BSc in Computer Science from Calcutta University in 2019. After that, I worked at Amazon as a seller support associate. So I had always been interested in data science, so that's why I took up this course.
Great, wonderful. Thank you. Data science is your interest. Sambit Kumar.
Yeah, hi sir. I graduated in ECE from IIIT Delhi. Now I'm currently working in Rakuten Mobile as an associate data scientist.
Wonderful. Pleasure to have you here, Sambit. Swapnil Kumar Srivastav.
Sir, I completed my BTech in Computer Science and Engineering from Guru Gobind Singh Institute University, and currently I'm working in Infosys as a test engineer.
Cool. And you're okay. So you're working as a test engineer in Infosys. Good. Okay. So
Yeah,
Swapnil Kumar Srivastav is you just spoke, right?
yeah.
Okay, great. So Uma Shankar Verma.
Hello, good afternoon, everyone. I'm a working IT professional, and I did my BTech in electrical engineering a long time back. And I joined this course I was interested to learn something new. So that's it.
Great. So you're a working professional and you're learning how to learn data science and ML. Okay. Urvi Midha.
Hello, sir. My name is Uvi Madan. I am an economics graduate from Delhi University, and I graduated back in 2019. Since the past 2 years, I've been working as a data analyst at Razorpay, which is a fintech company based out of Bangalore. And I'm very excited and looking forward for this specific coursework in natural language processing.
Wonderful. Pleasure to have you here. Did we miss anyone out? I think we missed Angad Singh earlier and a few who have dropped out. But yeah, so if anybody is missed, please let me know and feel free to introduce yourself. We'll wait for about 5 seconds. I think yeah, we've already covered. So great. So I think let's go on to the class then. And as you know, this particular module is on natural language processing, and let's dive right in. And before I think we start the class, are you able to see my screen? So some ground rules: you can always interrupt me by raising a hand or um, typing in your chat window, or even better, if you can just unmute yourself and ask questions. I would like this class to be interactive. Okay, it is a very interesting topic. I was looking at the uh, words that have come up, right? Analytics, data science, machine learning, engineering, network automation, again, analyst, remote sensing, machine learning, cybersecurity, market research analysts, data science, as we would expect, systems analysts, IoT sensors, and fintech. So I think it's a very exciting bunch of class. You will not just learn from me. You will also learn by engaging with the class. So I think this time it is a little bit different. Earlier, I think it was all a group of working professionals from IBM. And this time I've noticed that it's not all working professionals and not specifically only IBM. So that's a very good thing, because then you have a very diverse set of people here and you can learn from each other as well. So you will not just learn from the class, but you will also learn by doing assignments together, by talking to each other, by discussing things. And I would highly encourage that. Okay, make this class as interactive as possible. Make use of this opportunity, because it is not, I mean, so the kind of depth that we will be teaching you in and with, you will typically not find on uh, on, for example, openly available courses. So we'll pick up papers, we'll discuss research papers, we'll discuss applications, softwares, of course, code, and state of the art developments, and we'll also cover the foundation. So I think it is going to be a pretty exciting journey for all of you. So if you engage, it'll be better for you. Just a quick show of hands. You can type +1 if you are a working professional, because I lost count, and -1 if you are not a working professional. I mean, just so that we know that, yeah, how many working professionals are here, because that actually drives a lot of flavor in the class in terms of um, practical versus theoretical. Okay, so so there's a lot of working professionals here, and so I'm assuming, since you're most of you are actually working professionals, and so you are looking for more practical, skill oriented way of implementing things in your work and in your jobs. And I think one of you said that you were looking for a research opportunity or a PhD, but now you have changed your mind. So at any point of time, if you think that you want to go into little more detail of the research aspects of any of the topics, please feel free to basically barge in and let us know. Okay. One more housekeeping announcement um, before we dive into the class. I'm pasting a link, pasting a code for the Google Classroom. I'm not sure if you've already got it. I don't see students on the classroom, so I've also basically uh, uh, shared this earlier with Vinodji, who is coordinating the sessions. So you can join the classroom. We will use Google Classroom for our interactions, for posting materials, slides, etc., assignments, general discussions. I would highly encourage discussions on Google Classroom. If you find something exciting and relevant in context to the course, feel free to post on the classroom. Feel free to post questions, exciting stuff, papers, developments, any open sourcing. I mean, every week I see a lot of open source products being released by uh, Facebook, Google, LinkedIn, etc., Amazon. So essentially, you or research groups, as you would know. So if you find anything exciting that you would like to share with your classmates, um, to make it a more engaging class, please feel free to do that. Okay, so please join the classroom, and that's where we will have lecture postings, we will have discussions, etc. All right, so these were the housekeeping announcements, and we've already had introduction, so let's just dive right in. So can you see my screen in the presentation mode? Feel free to unmute yourself and
Yes,
say
sir.
yes or no.
Yes, sir.
Great. All right. So so today basically it's an introduction class, and we will be um, in this particular module looking at NLP. What is NLP?
The natural language processing.
Great. I mean, there's a lot of other word usages for NLP as well. Neurolinguist programming is one, right? But in this particular, we are looking at how do we work with natural language and build models on top of that. It's a very important area of data science. I don't know how many of you are working or would be working with NLP. I was trying to understand from your profiles where NLP would come in, but I'm sure each one of you will be able to fit in something or the other that you will learn from this course. Okay, and before we go into the the course, I mean, you've introduced yourself. Let me just also introduce myself. My background is in medicine. I did my medical graduation, and then I did a PhD in computational biology. And essentially, my work has been at the interface of healthcare and computing for the last 15 years or so. And during this time, I've been engaged with various organizations, including as a visiting faculty at Stanford University. I'm currently an associate professor at IIIT Delhi in the Department of Computational Biology, and I've also been leading the Center of Excellence in Healthcare. So you would know that, I mean, so from here you would know that my focus area is in healthcare. But if you look at our one past year's research work, you'll find that most of it has actually been in the space of natural language processing for healthcare. So we work with data sets that make use of NLP models that can learn, for example, from social media, or learn even how to read the book of the viral genome, the COVID genome, just as we use NLP to read text. The genome of viruses is also organized in the form of words, which are called codons. And essentially, how do we understand the genomic sequence of the virus and predict surges? And I think that's a very important area. The second wave had really struck us bad. So essentially using NLP for various different aspects. Then we've also built models, papers accepted in areas where we have built in causality. I mean, how, for example, the coupling of what government bulletins was saying something about COVID, and how the Twitterati were responding to it. So there's a coupling. How to use data science and NLP to really see what leads, what lags, and how should we guide that. So those kind of things. And then, of course, I think one of the flagship projects that I will talk about in our later applications of NLP in healthcare is on Wash Karo, which was a completely NLP-based pipeline for raising water sanitation and hygiene awareness, specially applied to COVID. So it was an app that basically 11,000 people used before, just at the time when COVID struck, and to give instructions and to use NLP to match what WHO said and what was coming out in the news, to mine out the fake pieces of information, to provide the right information and in the right language, in the right format, bite-sized text summarized audio pieces of information. So it was a complete NLP end-to-end solution, recently accepted in Nature Scientific Reports as a publication. I'll be happy to share that more details. So essentially what I'm telling is that we have had an extensive experience with natural language processing, especially in the area of healthcare. But I think you'll be able to connect with a lot of other areas as well. For example, if some of you are financial analysts and you are wanting to track the trends of stocks, for example, and sentiment or emotions on Twitter, and then see, that's a very well known field of work that's already out there, right? But then pushing it to the state of the art, and how do you build context and models, etc. I think you'll be able to connect with some of those things, right? So where do we situate NLP in this whole data science ML analyst world, right? So you may be an AI engineer, ML engineer, data scientist, analyst, or at the interface. But where do we put ML, right? So essentially, I think you all know that AI is a superset. Anything which helps us makes decisions, automate some of the reasonings, right, and basically guide some processes falls under artificial intelligence. And can somebody give examples of earliest forms of AI, um, in terms of how systems were built in early days using AI?
Handwritten digits classification for classifying letters as per their postal addresses.
Do you know what techniques were used for handwritten digit classification?
Convolution neural networks.
Yeah, so that's why I said early days. So I mean, you guys are young, so I don't expect. But any other examples of what could constitute AI before that? Before, by the way, I think handwritten digit classification, the MNIST data set was used extensively uh, for early days ML, such as the neural networks, not deep learning or CNNs, but very basic neural network architectures, right? Perceptron models, etc. But any other examples of even before that? How was AI used?
Maybe things like to understand, I mean, sentiment, they could do term count, I mean, term frequency, something like that.
Yeah, we're not
Just
talking about
basic.
natural language. I'm just asking a question. Early days of AI, what were the techniques?
Used to
And
decode messages,
sorry?
decrypt messages from, like in the World War, the Turing machine was used
Yeah. No, so yeah.
to
So
decrypt Enigma.
yeah. Yeah. So basically, Enigma machine was a very sophisticated machine, but I think it was. I'm looking for that particular name which it was based upon, but I think yeah. So you guys, uh, rule-based systems, right? Even so, why is it a superset of everything? Because if you can encode something in rules, if this then that, a lot of, for example, early systems were rule-based. Okay, and then there were other forms of models like decision trees and so on, but rule-based systems were the earliest form where you say that if you observe this then do that, right? And and those were the, I mean, still a very um, well known and well used form of models that are currently in place. And that's why AI is a superset, because it includes a lot of different fields, including ML, DL, and other things. Okay, and rule-based systems, even evolutionary algorithms. Right? You may have heard about optimization algorithms such as particle swarm optimization and so on, genetic algorithms. All these, even some people say that okay, even logistic regression is a form of AI, which is a simple linear model. It's a statistical model, right? That's why a lot of statistical modeling also comes under AI. So anything that is basically enhancing and augmenting human intelligence, and helps us take better decisions or better understanding is AI. And within the AI is a subfield of machine learning, which I think in prob stats course you would be learning how machine learning is different from statistics. If not, I'll give some introduction later that what is the basic distinction between ML and statistical learning, right? So, and where did this divergence happen? I think the key divergent point in these is Bayes' rule. So we'll talk about that maybe later if we have to discuss the applications of Bayes' rule in NLP. But you must know that machine learning is a form where you learn from data, right? Instead of um assuming hypothesis and then testing hypothesis, which was traditionally done in statistics. Now, basically, we learn hypothesis from data, right? And then basically we fit models that can then tell us the goodness of it. Within that space, there is deep learning, which you must know is the booming field where we have deep neural networks and specialized architectures. So it's not just the depth of the neural networks, but also the specialized architectures, such as the convolution layers and um, the recurrent neural networks and the LSTM, which are very much extensively used in NLP as well, because these are used for sequence modeling, right? So for modeling sequences. So that is why NLP sits at the interface of all of these. It's situated, it covers all of these. Rule-based heuristics, okay? We'll talk about that, for example, in parsing. Some of the earliest known language models were about parsing, right? Noam Chomsky is the, you can sort of call him the father of linguistics. So, but the parsing models make use of rule-based systems and heuristics, right? Then there's other forms of AI. Uh, Pushan Srivastav, I think your chat is okay. So, uh, and then there is of course uh, there's of course deep learning. So deep learning is the form where basically we have ML, the applications of deep learning in natural language processing include transformer models, BERT models, language models that are currently used, for example, for training models that can work with Google scale data sets and predict what is the next word that you're going to type, for example, in your Gmail, or the next word you're trying to type in your Google search bar, and so on. All of these, and the GPT model, BERT models, all are example of architectures which make use of deep learning, and we will cover all of that as well. Okay, so but now, also, you must know that machine learning or AI has many different forms. For example, supervised ML, then there's unsupervised ML, then there's semi-supervised and weakly supervised ML. Can you give examples of each supervised, unsupervised, semi-supervised, and weakly supervised in NLP? Examples of supervised learning in NLP. Okay, come on, guys. Just uh, type or unmute and go ahead. What would you think is an example of supervised learning in natural language processing?
Maybe the prediction of text. Maybe, for example, if you are typing something and type a one word. I mean, just very simple example on mobile. If you type a word, it predicts what will be the next word. So that would be a very simple and daily use of AI applied to natural language.
That's actually generative modeling. No, it's AI applied to natural language, but we are looking for a specific supervised learning example. What is the difference between what you just said? That is a natural language generating model. It's a generative model that I should be able to generate more language. If I'm typing some text, it should be able to predict the next word. It is not necessarily a form of supervised learning, although there may be subtasks within that which may be used for that. But in general, it is a generative modeling task, and we will know what is the difference between these two. Okay, but I think, for example, Sambit Kumar is saying sentiment prediction, and that is correct. Any other examples? You can say out your name and say. So Vivek Kumar is saying language translation. Um, I mean, it'll be an extensively difficult task to achieve language translation using a supervised learning task. Okay, so um, neural machine translation. Again, I think you'll see the kind of models that are used for this kind of work. But if it has to do classifications, and you can imagine the large corpus that it'll have to classify each word, whether this word will uh, should classify as this the same word. It's going to be a ridiculous, difficult, and wasteful task. So Ronak Datta is saying Siri and Alexa. Let's think about what are the tasks. Siri and Alexa is, how are we saying supervised learning? Ankita is saying auto predict. Auto predict again is, I'm assuming what Uma Shankar also said, that you're trying to predict the next word, if that's what you meant. That is again a generative modeling task. Okay, so far we've had one good answer, which is sentiment prediction. But guys, supervised modeling is when we have a small number of classes, okay, into which we want to bin our text. For example, sentiment. Is it a negative sentiment? Is it a positive sentiment? Or is it a neutral sentiment? So you have three classes. Okay. Similarly, you want to, for example, say, is this text um having inappropriate language or not having inappropriate language? Binary classification. And you can train your machine, you can train your models using supervised approaches where you feed these two classes or three classes, right? And if you go beyond two, that's called multimodal classification, right? And uh, uh, so essentially, what will happen in that case is that your models will become less and less accurate if you have to classify into many uh, classes, right? So basically, um, now can somebody give an example of unsupervised learning in NLP, in natural language processing? What is an example of unsupervised learning? Please feel free to unmute yourself and discuss. I'm sure in data science.
News
Yeah.
article. I mean, we classify news articles into different categories. Those categories can be increasing in number. For example, Google News uses that to put things into different categories.
So, I mean, so when you use the word classify, that actually was a little bit off, but otherwise, I believe you what you're saying is cluster
Yes, sir.
documents. For example, if you want to cluster documents into types, for example, if you look at literature, your biology articles will come together, your physics articles will come together, economics articles will come together, right? You're not, you're
Right, right.
just as you have clustering approaches in data science where you don't have classes, but what you're trying to learn is a distance metric between documents. And what will happen is that based upon these distance metric that you learn, things will either be close together or they will be farther apart, right? And things that are close together form clusters, and things that form clusters um, essentially are usually uh, belonging to the same class of documents. So there's no supervised way of telling that this is a, for example, a cat class or a dog class, right? So, or a Shakespeare text versus some other author's text, right? You are essentially, you could, for example, take two authors' text like Dante and Shakespeare and essentially uh, throw it into a learning model where you can say, okay, these are Shakespeare's writings, these are Dante's writings, and then classify the new piece of document that we are giving, right? Otherwise, we just put it into a learning machine which learns the distance between documents, right? And we'll see how that can happen. How can you figure out what is the distance between documents? We'll see some of that. That's an example of unsupervised learning, where in this course you will also learn about how do you learn distance between different documents to do clustering approaches, right? And the semi-supervised learning and weakly supervised learning, which I believe are slightly advanced, and we will go to those as we get there. And but very upcoming areas, for example, weak supervision is a very important area. So that how can you create data sets without having gold standard labels? I mean, how can you program data sets to get some form of silver standard labels, if not gold standard labels, right? That's why it is weakly supervised, because your supervision labels are not perfect. You're learning those from data, and a lot of NLP applications actually lie in that domain also, which is called weak supervision. Okay, moving forward. So I just wanted to give a sense of where NLP is situated, what are the tasks in AI and ML it can do. So we will. I would recommend these two books if you are more theoretically inclined. I would highly recommend Dan Jurafsky's book. Dan Jurafsky is a professor at Stanford, highly prolific. You can read his papers, and I mean, you will get a sense of how many diverse fields he has actually worked in. But his one of his key areas of expertise is NLP and networks. So you'll find this book very exciting. But the challenge with this book is it is, number one, more theoretical, has very little practical examples, and also it does not cover the latest and the state of the art in models such as the transformers, BERT, and it does cover some of the vector space models, but not the state of the art models. For example, the attention mechanism and so on, which are now, I think, routine things in NLP. Okay, but if you want to get a sense of the traditional way of thinking about language processing, it's still a very relevant book I use to teach my classes as well. Okay, and the more practical book that I recommend, which you can, for example, follow. It's not too deep, so let that be a very upfront rider, that it's not a very deep book. I find it quite superficial, but I find it helpful, especially for working professionals in terms of running pieces of code. You'll see the code, you'll see some very succinct um, um, description, you'll see the explanation of what we're trying to do. So from that standpoint, it'll get you up to speed in a lot of different things in building real world NLP systems. Okay, so I do recommend both of these books. If you want to understand more deeply, especially the mathematical aspects and the statistical aspects, follow Dan Jurafsky's book, and then also then follow it up with some practical learning and applications with the O'Reilly Practical Natural Language Processing book by Vajala, Majumdar, and Surana. Okay, so these are the recommended readings for this module. and feel free uh, to post any questions on the classroom. As I said, if you come across any issues while you're reading the books. Okay. So what is coming up in the next few weeks, right? So the time allotted for the NLP, we are going to cover a wide variety of things, and that's why it is exciting. So today we are just going to have an introduction into what is coming up next, brushing up of some things that you may know, something you may not, and so on. But then we will begin with very simple things such as regular expressions, right? And so one thing, if you know Python or if you know R, I think Python is the best place to learn NLP. It is a very strong advantage for this module. So let's just have a show of hands. How many of you know Python and have coded in Python? See, there's about 22 people here.
So we had a subject in the previous trimester for Python.
Perfect, perfect. Which means that you already, yeah. So great. This is going to be very helpful for, yeah. So almost every one of you is saying that you have, not almost everyone, but a lot of you have actually said that that you've worked with Python. But since you have had an introduction, so most of the codes will be in Python. Okay, so any codes that I share with you will mostly be in Python. Okay, because that is the most commonly used language for NLP. Okay, for probs and stats, I would recommend, for example, R. But for this course, I would say that having a good understanding of Python is actually a plus. Okay, so let's go forward to, so we will start with n-gram language models, how n-grams are used in language modeling, and then slightly advanced things in standard natural language processing, such as part of speech tagging, right? For example, how do you know? How does the machine know? Or how does the model know? How does the computer know? Whether it is a noun, phrase, or is it a verb? Is it an adjective, right? So what are the so how do you tag parts of speech? Because that is really important for understanding. Although the name of the course actually of the module is natural language processing, however, we will be covering a lot of aspects of things which are beyond natural language processing. They're called natural language understanding. How do models understand language, right? It's not just process language, but can models actually understand? And you will see a lot of examples that will come up in later parts of the course, especially in text summarization and embeddings, right? So we'll talk about models that help in parts of speech tagging, parsing, word sense, right? Disambiguation of words, ontologies that can be used to, for example, understand the language better. But then after this particular word sense, we will jump into the more advanced forms of NLP, starting with the vector space models and distributional semantics. Okay, because that's when we start moving from the traditional forms of NLP to the more AI, ML, DL forms of NLP, where we start representing words, documents, right, in the form of vectors. And then essentially you must have heard about word-to-vec models, you must have heard about transform models and so on. So how do we learn embeddings or the latent dimensions of text is what we'll cover. Okay, and then of course we'll cover classification. We already discussed what do we mean by supervised learning. So classifying documents, right? How do we summarize documents? It's a very difficult task for the computer, because to summarize something means to understand it, right? It's a very high level intelligence thing that if you all must have written Prezi in your schools and colleges, right? Which means that you have to first understand and then collapse and compress all of that into something that is still making sense, but yet it is communicating the abstract of the so it is a very difficult task. But how the state of the art NLP models are achieving and examples of those in summarization. So also codes, tools, we will talk about papers that basically have used it or built it or open source these things. So you'll learn all of that. And then we will come to applications of NLP, which will include healthcare. As I said, my key area of focus is in healthcare. So I'll basically show some applications in healthcare domain. Also e-commerce, chatbots is something that you may even build, right? So we will have a couple of, for example, assignments on building chatbots using frameworks such as Rasa or the Dialogflow, simple Google's Dialogflow framework, which is a very high basic tool for building chatbots. So from very basic like Dialogflow, which is a more rule-based thing, to advanced forms such as using embeddings that you will have learned before into your chatbot systems using Rasa is something that you'll learn as a part of this course. You'll also learn about social media analytics, sentiment analysis, emotions analysis, and so on. And finally, what does it take to deploy NLP systems or NLP software? Because most of you are working professionals, you may be asked not just to conduct research, but also to actually deploy some of the models that you've built, for example, to capture something which may be useful for your companies, right? So basically that is the overall content of this course that we will be covering in the next few weeks. I'll stop here and take questions if you have any.
You were talking about two things. One was sentiments analysis. Other one was, I think, emotions analysis or something. So could you please elaborate more on those two things? I just wanted to. I'm trying to distinguish between like what the difference between these two.
Oh, thank you for that question. I think it's you will when it comes to the that lecture, you will understand clearly what is emotion, the difference between emotion and sentiment. Sentiment is just, you can classify it into three: positive sentiment, negative sentiment, and neutral sentiment. Emotions are varied. Okay, for example, anger, empathy, right, compassion, or fear, anxiety, right? So emotions are a much larger set, and these are very different things. And you basically sentiment analysis is a very superficial way of saying whether it is positive, negative, or a neutral sentiment. So you will learn about tools that will help conduct the emotion analysis upon for example, a corpus of text. Okay, and I will give examples from our own research work and also from the papers. For example, we'll discuss a paper which will talk about I think deceptive hotel reviews, right? So if hotel reviews are deceptive, how do you detect that using emotions? It's very hard to detect that using sentiment. And then how do you use those approaches to go beyond emotions? Because essentially these are models that help you create lexical categories on demand. And that is also the title of the paper, which is called Empath, that how do you create lexical categories from a piece of text on demand. And the way they introduced the paper was through emotions, because these are hard to do. But then you can, for example, we have done that for mining vaccine beliefs for COVID. Okay. And how has vaccine hesitancy changed? Now that was not present earlier as an emotion, which we created a category for in mind. So we'll talk about those things, but I hope I have clarified some of that. Any other? Yeah.
Yeah. Thank you. Thanks a lot. Just maybe subsequent question on this. I'm curious. Curious to know about you know, emotions. Like, is there any work which is going on? Like, maybe I'm sure. I think somewhere in the world, um, emotions. I think. I mean, there's a positive emotions and there are negative emotions. So, is there some work? Maybe not to discuss here, but I would like to like read something about, you know, where you read the emotions, and then something which is happening right now to transform, not transform, but you know, move that person from negative emotions to a positive or more positive emotions or something like
Yeah. No, I completely think there must be. I will share a few papers with you, for example, that work with the text analytics, and then essentially the second part that you've just said is a little slightly more tricky part, which is a part of something called nudge. How do you nudge a person's behavior or emotion towards some action? And actually, nudging is a Nobel winning field. So I'm forgetting the name of the Nobel laureate who actually got.
that. I think Thaler, I guess.
Yeah. Sorry, say that again. Taylor.
I
Yeah,
think
yeah,
it was
yeah.
Taylor or Thaler. Yeah.
Yeah, Richard Taylor. So yeah. So basically, the nudge theory, combining these two different things, is very interesting. And how do you nudge people towards taking the right set of actions? So thank you for asking those questions. Very exciting and important points. Any other questions from anybody else?
So, although I don't know if it's relevant or not, but I just thought that the sentiment analysis thing, like if we use it, like we could actually, if there's a movie coming out and there's a lot of buzz around that particular movie, and a lot of people are posting, like giving their sentiments, like, and there's a lot of buzz around that movie, so like it'll somehow predict the revenue of the movie also. Will it be a blockbuster or something
Yes, a
like?
lot of work has happened around that domain, Ankita. I think that was one of the first things. There's a large data set called the IMDb data set, which I think you'll find it on many Kaggle challenges and so on, where exactly this question has been asked, and sentiment analysis has been used for that, I believe, for quite a bit. And if even if you don't know, I think everything that we do on the internet, I think we have a footprint that is being constantly mined by companies. So certainly, I think some of this is already going on. But the specific use case of looking at revenues versus how people are talking about that movie and how much of that can be modeled, I believe, is already has been done, and we can share some papers on that or some examples on that. But I'm sure if you find some challenges in Kaggle, you'll find these things. Any other questions, folks? But thank you for asking that question, Ankita.
Okay, welcome.
Okay, if there's no questions, we can move forward. Okay, so let's talk about, so since this is an introductory class, okay, we'll take a break at about 3 p.m. and maybe 5 to 7 minutes break, and then you can come back. Essentially, but let's before that just look at what is the classical way in which natural language processing is done. Then we'll talk about why do we think that NLP is hard? What are the challenges with NLP, right? I mean, but before going into the challenges, let's assume that there were no challenges in terms of, for example, people using um, different forms of words, right? Or misspelled words, same word meaning different meanings, right? So on. Forget about that. What is typically done as a pipeline in classical NLP? You have a set of documents, right? And when we say NLP, essentially we are assuming that these documents are mostly always just text, right? But that is not always true because, for example, our work in virus genome sequences, I mean, it's text, but it's not language. I mean, it does have some grammar because the way DNA sequences are built follow some pattern, right? But it is not natural language as humans have created it, right? So we are using the word documents in a slightly larger sense, where we are saying that there's a sequence of letters, symbols, right? And then the sequence of symbols are actually um, arranged in documents, right? And this is typically called a corpus. And a corpus of documents then goes through some pre-processing steps, right? We don't directly go to building sentiment models or classification models or entity extraction. We typically start with some very basic steps, okay, which, for example, tokenize these documents into bite-sized pieces which the model can take, okay. And these tokens may be words, these may be sentences, these may even be complete document as a token, okay. For example, the tokenizer for the BERT models, which is a state of the art right now, is a sentence level tokenizer, right? So it differs. That tokenization means that we are breaking up the document into chunks. These chunks may be even letters, right? Letter level tokenization. And we'll come to that later, that what are the advantages of each of these? Why would you want to tokenize, for example, the word tokenize into TOKENIZATION, right? There's some advantages and some disadvantages to that. Similarly, if we are tokenizing into words, we say feature extraction. Now we say feature is a token, extraction is a token. Similarly, we can have tokenization at the sentence level. And then these tokens essentially are given some tags, okay? Each token, for example, you may say, okay, this is a word, a verb. This is a noun. This is an adjective, preposition. It's a noun phrase, okay, and so on. It's a verb phrase, and that's how basically language is built. Obviously, we do some pre-processing steps where we remove things that may not be informative, okay, and those are called stop words. For example, the right. So, and you can create your own stop words which may not lead to understanding of the language, although for the latest models, the recent models, we use stop word much, we remove stop words much less often. But for traditional models, what would happen is, if you're building statistical models, the stop words will be so many, every sentence would have a. So what will happen is the count will be so many that it leads to very skewed distributions. That's why it is a part of pre-processing. Okay. Then you go on to, for example, building features from this pre-processed text. Okay. These features can be as simple as what are the frequencies of words. Okay. For example, maybe Shakespeare uses a certain word much more often than Dante. Right? We are not even talking about word combinations or sentiments or emotions or themes or style of writing. The stylistic way of writing is a very interesting field in AI, but just very simple thing is the word usage in terms of frequencies different. That is an example of a feature that can be used to um, train a model, right? And essentially, these features are then put into models for learning classes, or for example for unsupervised way of learning and so on. And then the output things are, for example, you can say what is a sentiment, you can classify, you can extract entities. For example, if you're in healthcare, you might want to extract drugs from all the pieces of text. How do you know that? Okay, so named entity recognition, or you might want to extract all diagnoses. Similarly, you can conduct named entity recognition for sports articles. Okay, if you're into sports, how do you do that? So, and you can extract entities, you can translate, you can even model topics, themes as they are present in the text. Okay, so these are the standard essential classical. I mean, I wanted to give this slide so that right at the outset of the class, you know what is the overarching process in which NLP is thought to perform like. Of course, each of these will have their own nuances. Many things which the dot 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 at the end will include many other things that we have not put in this. But if you think in this framework, for real world deployment, you will be good. Since you are working professionals, for real world deployment, you probably will not be just working on, for example, a neural machine translation model. Okay, that will be something being done by a research lab. But what you might be doing is you may be building a pipeline that will take Hindi texts, right, tokenize, do part of speech, remove stop words, extract features, model, infer, and then maybe give topics in Hindi using neural machine translation. So remember, this is the overall pipeline that typically will be followed by you in your real world projects, and we will focus a lot on real world deployments and projects because this course is meant for that purpose, right? Practical understanding. So we'll stop here. It's 3:05. We can meet again at how much? I think let's meet again at 3:10. Okay, if that's fine, or do you want a slightly longer break? 3:10 or 3:15? 5 or 10 minutes.
I think 3:15 will be better.
Okay, let's take a 10-minute break and reconvene at 3:15 to continue with the remaining of the class.
Okay, thank you.
Thank you. Okay, is everybody back? Please give a +1 if you are back. You guys are back. Wonderful. Great. Thank you so much. So we'll continue with our NLP discussion. So classical NLP, as we were talking about, right? So follows this particular process, and in classical NLP, you can see that examples of this, which we'll talk about, include models which may look like something like this. Okay, for example, professional boxing is a sport, and maybe it is like another sport like wrestling, right? So how do we build such lexicons which help us reason with language? Remember, we talked about natural language understanding, right? So we talked about, for example, sumo wrestling is a form of grappling, okay, or wrestling, and it is like professional boxing. Now, if your system knows this, you can actually start building your reasoning systems with rules such as this. Now, this is not AI. I mean, this is AI, but this is not AI as you would call AI or we would call AI now, in terms of having systems which, for example, use deep learning. But still, these ontologies and lexicons are still very much used in natural language processing. For example, the semantic web, right, is a big field where just understanding what documents on the web, how do they relate to each other, right? And all of this, you can imagine that such systems can help you reason and build classification models, build clustering models, and so on. Okay, these are lexicons that are built over time. We'll spend some time in the WordNet class on this kind of a lexicon, typically based upon dictionaries and thesauruses, where people have built these by saying, okay, this word has these alternative forms as well, or alternative synonyms as well. They may be not the synonyms, but there are also hyponyms and meronyms, which you will learn what exactly do they mean. Okay, antonyms, synonyms and antonyms we are considering the same because they are in the opposite direction. One is just the opposite of other, right? But then if a word is a part of some other thing, like so, um, that is a meronym. But if it is a child of something, it is a hyponym, right? So we'll learn about all of these things. So these systems are still very important in natural language processing. Okay, and a lot of classical NLP has relied upon um, lexicons such as the WordNet, and we will have a class that will be dedicated to WordNet. We'll have a class that will talk about regexes, the regular expression, okay, rules, uh, what are context-free grammars, what are ontologies, right? We just learned something in these kind of relationships, right? You can actually take these a little bit forward, and for example, this is a generic um, architecture for text engineering, okay, which basically you can see that it has actually labeled different parts of speech, different entities, and then um, it has actually created an ontology. For example, it has a property, it is associated with the lexical resource, and so on. Okay, so essentially having a structure to the language that we are looking at. Think about these systems as very sophisticated but hand engineered systems of natural language processing. Okay, a lot of it is used in annotations and so on. Not that it is used now; it's mostly superseded by the deep learning form of NLP, but still something very important to know about. Okay, then we will talk from rules, and we will transition into statistical learning and machine learning. Okay, where essentially we now don't define rules, but we start working with data. Okay, but we'll start with very simple models. For example, a model that will look at the sequence of words, which is natural language processing, bracket start, NLP, bracket end, right? And you see that there's a start tag, right? And then there's an end tag. And then it is saying natural is an adjective in this case, right? Language is noun, processing is noun, and so on, bracket, noun, bracket closed. Now, what is happening here? A statistical model can actually learn such a sequence that if I see a bracket after a noun, okay, there would be a noun. So it may not be able to say natural language processing bracket open NLP bracket close, but it might be able to learn adjective noun noun bracket noun bracket, right? So these are statistical rules because this is how language has been constructed. And we will learn about such statistical models that work with transitions such as this, okay, such as the hidden markup model and so on. Okay. Then we'll talk about a slightly more advanced form of sequence, because remember, every sentence or every document or that we are looking at, these sentences are nothing but sequences of words. And as I said, if you even want to go further, these are nothing but sequences of symbols. And deriving meaning from sequence of symbols is the exact thing that we are trying to achieve in this NLP module. Okay, how do we derive meaning from a sequence of symbols? Okay, and in that, the next thing that we will discuss is how does a deep learning model work in that direction. And in this particular case, for example, this is a recurrent neural network model, where again you can see that there is a sequence of words, but now this is being achieved via specialized neural network architectures, okay, and LSTM cells. So instead of having a statistical model that fits probabilities, now we are actually learning from data and learning these hidden representations that can help us learn, if I give a word, what may be the next word. Okay. And these are the type of models which you would say are neural network models and long short-term memory models. This can also be achieved by using CNNs, by the way. Okay, for example, if you're looking at, I like this movie very much. Okay, and then you run a convolution, just as in a image model, you run convolutions over patches of image, right? So, for example, if this square was a image, you would run a convolution operation over. We will learn what a convolution operation is if you don't know. You will run the convolution operation over such square patches which will be overlapping, which is equivalent of saying that I run a convolution between I like this and like this movie very much, and so on. Okay, so you can think about this as a 1D convolution operation, which is building such feature maps from language, right? And then essentially, once you have learned the filter maps, you can use the last layer to do a lot of tasks. You can do things like sentiment classification, hate speech detection, and so on and so forth, etc. Okay, if you are, for example, building two classes. So what I'm trying to tell you is that a lot of neural network architectures have already been in place for learning these sequential models, including such RNNs, LSTMs, and CNNs. Then we will talk about the main core of this course, okay, that will be built upon, that we will be building upon, and that is called a vector space model. Okay, and here I'm showing just an example of the word-to-vec model trained with a skip gram approach, where each word, for example, the quick brown fox jumped over the lazy dog, each word is now trained in its context and as a vector in an embedding space. And don't worry if you don't understand the meaning of these words right now. What is an embedding? What is a representation? What is a vector space? That all will be covered in the lecture when we will talk about vector space models. Okay. And then these vector space models look something like this. For example, that the context of the word, if this is the word that we are trying to model, it looks at, for example, the surrounding words. And we'll not go into detail today, but how do we build neural network based models, word-to-vec models, which basically will help you predict which word should come next, right? And that will, in our series of lectures, lead us into a highly advanced form of language modeling, perhaps the most important and the most advanced form of models available to us as of now, which I think all the big companies such as Google use. It is called the transformer architecture. And the transformer architecture was used for NLP initially, was built because there was one key aspect to it, which is called attention. Okay. But now the transformer architecture is used for everything. Even for vision models, we are now seeing transformer architectures. But it is a key jump from understanding language as we used to do before it, because before it we were looking at these sequences here, right? So we are looking at the sequences of words, be it through a word to vector model or through a CNN model where we're looking at convolutions over sequences, or through a RNN LSTM model where we are building these long short-term memory representations of sequences, or through this statistical model where we are saying, okay, this is the way the statistics tell us that what should be the next word. But now we don't do this in transformer models. We look at chunks, bigger chunks together, not a sequence. And we'll come to that, how language is understood these days by the models such as BERT and GPT-3 which make use of transformer architectures. These do not model sequentially, okay? And since they do not, it is like a baby learning language. Initially, the baby will, for example, the child will learn letters, right? But then they do not understand unless they understand the full sentence's meaning itself. If they just focused on a word, they will never understand the sentence, right? So essentially, it is looking at the sentence level information, or maybe sometimes even larger, in terms of understanding, and then zooming in and zooming out repeatedly. We'll see how that happens in the current BERT models, right? So the very same thing that we discussed earlier that was being done by in the classical NLP now is replaced by some deep learning based NLP architecture, where we do still do pre-processing, but then we use some deep learning architecture to learn the hidden features, the features of those texts, typically through some dense embeddings achieved via word to vec, doc to vec, glove, BERT, transformer, etc. Once we have these features which have been learned from the text, these then can essentially be fed into models that can classify the same things that we were looking at earlier, right? Sentiment or classification or entities, translation topic, etc. What has gone away here? Earlier we were building those features. Remember, we are for example, what is a word count and so on. Here we are not building statistical features. We are actually learning features from the text itself. Okay, so this is the key part where we learn the dense embeddings, and we will learn in the class where we talk about dense embeddings about how does this happen. Okay, we'll spend one full lecture on the working of a transformer model, and I believe this might be theoretical. You might feel a little bit lost here, but if you don't know the transformer model in full detail and how does it happen, it is very difficult to really understand the state of the art advances such as summarization and annotation, captioning, all of that. Okay, so we will understand how does this beast, which looks like multi-headed attention, so many layers, and each of these layers is doing a very specialized task. We will break this down into each of the components that are being mentioned here. And this very famous paper from Google, Attention is What You Need, we will actually uh, deconstruct this paper and understand each of these components in full detail so that you fully understand how do transformer models work. Okay, we'll talk about this. Obviously, after transformers, we'll talk about some applications such as the bidirectional encoder representation of the BERT models. Okay, again, these are used by state-of-the-art approaches that NLP has led to, right? So, but then essentially we are looking at some of these applications that how do we train such models using language masking, etc., right? So how do we train such models which look so complicated, such as this? Questions so far? I don't expect you guys to understand all of this. Today is an introduction class. We are just giving you a whirlwind tour of what is to come up next in the coming classes, and hopefully to get your interest peaked. If you feel lost, please don't be. Everything that we are talking about will become crystal clear. Okay, just know one of the reasons I wanted to give this whole tour was to understand from where have we come, where have we arrived at, for example, such architectures. Okay, and even going forward, that now even transform models have become something like, okay, they have become something to experiment with our own architectures and build models. uh, for example, this BERT model uses transformers to learn to understand language by reading it from both directions using transformers. That's why it's called bidirectional encoder representation. Why is it called an encoder? Because it's encoding, it is learning the underlying principles of language. if you think about it, it'll be mind blowing when we get there on how these ideas have come into form and have led to some of the models that are actually used for each of the tasks that we do in NLP. Okay. Similarly, for example, this is an example of a BERT transformer model used to train a summarizer model. Okay, so this is a state-of-the-art Pegasus model, which can summarize text for you. There's a Google blog which you can visit here, and you'll see some examples there. Why is it so interesting? It's so interesting because if you go there, you'll see that how a model that has been trained on language can learn mathematics from language. By mathematics, I don't mean mathematics like doing complicated mathematics, but counting, very simple counting. But think about it. When we get there, you'll realize a model, a computer that has actually, without telling it, a model that has learned to count without telling it to count from text. Isn't that something which is, to me at least, it is mind blowing and completely, it tells us that we have gone into that age where now abstraction of language has started happening and computers have started understanding some of it. It doesn't mean that we are perfect. Language models have a lot of imperfections and a lot of problems. Okay, these models, such as the BERT model and the GPT model, they are trained on internet scale, Google scale corpuses, which means that they have a lot of biases. A lot of papers have actually been written which show how biased these models are, racist these models are, right? For example, if you type a Muslim name, it might come up with some examples of how they may kill or lead to a terrorist attack, right? But if you give a Christian name, and this is an actual paper, okay, and you can find why language models are racist. But the point is, by themselves, these are just technologies. You will learn how do these work. You may learn how can we make them better by building more inclusive data sets, and that is the current state of the art research. So we are nowhere close to saying that the models can now, we can relax and language models can do the job for us. They can abstract and summarize and do everything. These have a lot of inherent biases, but even the baby steps that have been taken in the directions of these models are mind-blowing. Okay, so as any technology, we will perhaps overcome these challenges as well. Okay, but this is how you will learn how to summarize text using a transformer model. Then we'll talk about applications. Okay, examples include in healthcare, right? Where, for example, if you are assisting a hospital, you can assist in many of these different things, right? You may help discover drugs, and you may think that how will NLP help in that? There's a vast amount of literature that no researcher reads, right? Because there's millions of articles. Who is going to read all those articles and make sense out of that, right? Essentially, um, discovering knowledge from text is something which is again a very important class. And I'll show some of the examples from our own research work, where we have led to basically some COVID-related research of generating evidence from the research that has been published over the last 1 year. Okay, you may think about developing precision medicine. What does it mean? You want to create the right medicine for the right person. Right now, we are just giving the same drug for diabetes to all people. But there may be more precision that can be built by if we were able to mine a lot of text that is available in the hospital systems. Not in India. India is getting there. You may be aware that now we have a health ID system coming up. But that's something I teach in another course, not in this course. Um, but essentially, I think you may be aware that there is the National Digital Health Mission and its components, which are now leading to every one of your personal health records. If you go to a doctor in the next 5 to 10 years, hopefully five or maybe even less, your personal health record, longitudinal health record, is expected to be available because you will have a health ID and a linked record. Okay, and that will help achieve precision medicine, because who is going to read all those texts, right? And millions of them, and then ask what medicine worked best in a patient like me across India? Is a single doctor going to do that? No, right? So those are examples of things that are like next generation but already happening. Simplest things are like clinical decision support, where, for example, you want to tell a doctor that this patient is going to get serious in the next 24 hours. And I'll give examples from our own research in ICUs, where we have built clinical decision support using NLP for ICU settings like shock. Okay, that's a project that's ongoing for the last 5 years or so at AIMS, in the Department of Pediatrics, where we have actually built these. Right, and then there's many other things. For example, can you create a better transcription system for a doctor so that they can actually recognize speech, transcribe it for you? Somebody said Siri Alexa, right? But Siri Alexa for doctors, right? And then as an assist, all these are examples where you can create more research, you can help in better treatment, you can capture data. Population health, right? Where you're not looking at a single patient, but you're looking at, um, for example, if you are sitting in the national medical register of cancer, let's say, an MRC, okay, and and you want to now understand that what are the social determinants of, let's say, cancer outcomes. Are you going to read all the text? How are the models being used for that, or how can they be used for that, and so on. Something that is very always very important in industry's revenue cycle. You want to have risk adjustment, how is paying, how much should they pay, and so on. Very important things for healthcare, but in general, right? So these things will actually be covering about, and of course having analytics and reporting, having descriptive analytics, right? And these three terms I think you should remember always: descriptive, predictive, and prescriptive. Okay, especially in healthcare, but in general also. I mean, these are like levels of reporting that you would do in your data science exercise. First is you can describe your documents. Can somebody give an example of what is a descriptive analytics example for text? Can somebody tell any example?
Sentiment analysis is also a descriptive. It describes what text tells, right?
Well, when we say descriptive analysis, we are looking for some numbers, right? So yeah, so I think you can count sentiment analysis as descriptive, but is there some very common representation that you see that will be descriptive? Word clouds, for example, right? Will not spend a lot of time, but histograms, okay, doing tests of significance. We are describing your data, that this is how my data looks like. Okay, so those are all examples of descriptive. Now, can somebody give example of a predictive analytic context? Plus one, guys, if you can hear me, and if you are awake and still with me in the class. No plus ones? Okay, so Example of a predictive analytics. We talked about supervised, unsupervised, right? So we're just getting introduced and getting used to these terms of data science and machine learning. You can always please ask questions because I may be using these terms, right? I don't expect you to know all of these terms because it's healthcare specific. That's why I just focused on these three because these are common to all data science. We talked about unsupervised, supervised, right? We talked about ELML, AI. But what is descriptive, predictive, prescriptive?
I don't know the example, but predictive, it's right. It's something tells about the future, predictive, prediction.
Okay, so all kind of models that we talked about before, which lead to some classification, okay, or for example, using text, if we are saying that is this patient going into, let's say, shock or sepsis or COVID, right? That's a predictive classification, predictive modeling. But many actual real world models that you would like to build is not just for predictions. What will you do with the prediction unless you intervene with the model? Okay, I mean, you take some action with the model, right? And we will understand why are these different, not just in the context of NLP, but we may spend a class on understanding, or less than a class actually, on how do models gain the understanding to actually become causal models. What does causal model mean? That it becomes now a prescriptive model. For example, if a model is not a causal model, you may be for let me give you an example. Let's say you and your friend um, go in the same car to university. Okay, but the car is yours. All right. Now one of you is a driver, right, and the other one is a passenger. Okay, you may end up actually, for example, if you wanted to intervene or to change something, okay, you may intervene on the passenger, but that will not lead to a change in the outcome because the driver is still in control. But if you intervene on the driver, right, things may change. So how do you learn these driver passenger relationships? Okay, and this is very common. For example, when we're looking at all models, there's so many associations. These are called associations. There's so many associations that you might think, okay, so uh, from text we learned that let's say uh, I don't want to use the wrong example for healthcare, but let's say lactalbumin is a molecule that is predictive of COVID outcomes. Now the question is, it is associated, but does it also mean that if I reduce lactalbumin, it will change COVID? No, because it may not be a cause, it may be an effect. It may be a passenger for COVID, in which case changing that will not lead to anything different, it will make any difference to COVID because it is an effect and not a cause, right? So how do we build models that go from descriptive to predictive to prescriptive? We will spend half a class or so in addressing this challenge of causal modeling with language. Okay, and this is important for healthcare, but is also important for most other fields where you will be taking action on the models. Okay, I hope this was clear, and we'll obviously spend more time on this when we talk about NLP applications examples in healthcare. Any questions? Then we also talk about other applications such as social media. Very important field. You might think, what is so different about social media when it's still text? But no, it is not the same text. Okay, I mean, so social media is a completely different ball game. That's what makes NLP so hard. There's so much. I mean, if you think about the the rigor, if you think about formality of speech, social media has a very special space and place, right? I mean, this is an example of what happens on social media in 1 minute, right? And you think that 1.4 million people scrolling Facebook in 1 minute are using formal language? No. Or 2 lakh people tweeting, are they using language that is easily understandable by models? Twitter is a completely different game because you have 140 character limitation, right? And that makes us do some very uh, put emoticons, compressed language, all of that, right? So essentially, um, for example, here is an example. My students told me about a new word, new as in new to the vocabulary as well as new to me. Found it in the Urban Dictionary, yeet, right? So, but then it's not just a new word which is yeet, but now what is the past tense of it? Would it be yeeted or yot, right? And you'll find a hashtag new word. So this is the kind of conversation that happens on Twitter. Now imagine your machine learning system trained on legal text and trying to find out yeeted and yot, and you can easily imagine that special ways are needed to to treat such kind of language. So we'll spend a lecture on understanding how social media analytics happen with NLP. Okay, and essentially looking at the formalism of speech from legal documents to casual speech to something which lies everywhere in between. Chat. And there's also very interesting things. I mean, it's just not one language. I mean, this is still fine, but there's something called code switching, right? So in the middle of English हम हिंदी बोलना शुरू कर देते हैं and then we go back to English. और से बोलते नहीं हम लिखते भी वैसा है, right? So you'd see that these languages switch. And even when we write, how does the system learn that? Okay, so all those challenges are very interesting challenges that you have. So you may build a very nice and clean system, but then ultimately it has to take into account all these challenges. Let's skip this right now. We'll talk about sentiment analysis and we'll talk about emotion analysis. This was a question that was earlier asked, right? And we'll talk about Luke, which is a standard emotion analysis tool. We'll talk about a counterpart of Luke, which is called Empath, which is based upon deep learning. We'll study the Empath paper. It's a paper from Stanford, and we'll study the paper of how did they actually build the mood of Twitter and how does it change the time of the day. This paper also talks about the deception of hotel reviews. We used it to, as I said, to understand how government emotions and moods get transferred to Twitter moods. When I say, I mean causal. Okay, I'm not saying association. Which one leads to other? I mean, and that's interventional because, as I said, which is driver, which is passenger. Understanding these couplings of emotions, that's a published paper that we'll discuss from our group, and I hope you'll find these kind of things interesting. So I think that's the basic overview. I didn't cover chatbots in this because that's also something that we'll talk about, looking at RASA frameworks and dialogue flow. But these are the applications in healthcare, social media, chatbot, e-commerce, for example, building models on top of these, which basically will be used uh, to gain insights into the systems and to deploy systems, right? And one last lecture that we will cover on the real world deployment of NLP and what does it need. Okay, it's not just learning how do you work in the middle of a team with the team in the deployment setting. We'll spend at least a lecture on that. What are the tools? What are the ways? What is MLOps, right? And I think what are the operations that are needed to deploy such systems. And that is where basically we will and the NLP section of the course. And during this time, if you find any topics that you find interesting or want to go into more details, please feel free to post these on the classroom. So I hope every one of you have joined the classroom link. Some of you joined late, so let me actually post the class invite code again so that you can join it, and let me know if you have any issues joining the classroom. Okay. And let me see how many people are actually there right now. Okay, I can see that there's 20 students, so 20 of you have actually joined, so great. And in the stream, I've already posted the link to this class. This is a link that is a persistent link. Please feel free to put it on your calendars, and we'll use this link for all our classes. Okay, and we will share I think we'll have a TA starting next week. So by then by that time, before that time, I will be sharing the classroom recordings and the classroom lectures. Today we don't have a quiz or an assignment. It was an introduction class, but if you have any questions, please feel free to ask me. We still have 5 minutes. So today it was supposed to be 3-hour class, but I did not want a 3-hour class today because I also have prior commitments. We will cover up the 1 hour maybe tomorrow, or we'll figure out today. As I said, is Bhaiya Dooj, we want to really not take 3 hours today, but we will cover the 1 hour that we missed today. So don't worry about that. Any questions?
No, sir.
No, nothing from my side.
Okay, great. So if there's no questions, we can stop now, and feel free to post questions on the classroom if you have any. Thank you, guys. See you tomorrow, 2 p.m. Take care.
Thank you. Have a nice evening. Bye bye.
Thank you, sir. Thank you, sir.
Thank you. Bye bye.
Thank you, sir.
Yes.
Thank you, sir.